My name is Chad Hosein, and this is my project for EEL 2161, finding the zero input response of a second order linear time invariant system using C. The problem statement was defined to create a C script that would find the zero input response of a second order linear time invariant system, d2y plus a1 dy plus a2 equals 0, based on coefficients a1 and a2 and initial conditions y of 0 and y dash of 0. The approach that I use for this project, based on the requirements outlined in the project assignment, was to create a header file to find the characteristic roots of the equation, as well as employing the use of pointers to access these coefficients and roots between the header file and the C scripts. Also, based on the project requirements, I had to create user-defined functions and conditional statements to determine the equation. Similarly, for part 2, there were the same UDFs and header file used. However, now I had to also include text files, one to read data and then one to print results onto. So let me walk you through the code. First off, we have the header file. As you can see here, I defined it to be named as my roots, and I created a user-defined function within this header file that would find the roots of the given equation. So as you can see, it takes arguments but does not return any value, and it uses the discriminant and conditional statements to decide how lambda1 and lambda2 should be equated. As you can see, lambda1 and lambda2 are both pointers, which would be used in the scripts, and they are defined by the user input coefficient as well as the discriminant, which it would have been calculated by. So there are the two real roots case, repeating roots, and complex conjugate roots. So now for the part 1 of the code, as you can see, I included my roots here. And then I defined my 3 user-defined functions, which also take arguments but don't return any value. And they also employ the use of the lambda pointers, as well as 2 more pointers, C1 and C2, which are the coefficients of the characteristic equation. The code starts off where I define some variables and prompt the user to input a1, a2, y0, and y.0. And then I call on the quadratic function from my header file to find the values of lambda1 and lambda2. And then I also have a discriminant function here, which variable, which would find the discriminant for this case, this conditional case, where I would call on each user-defined function based on the type of roots to determine the characteristic equation. These user-defined functions would find the values of C1 and C2, hence the use of the ampersand, and then it would print each characteristic equation, including the roots and the coefficients. At the end of the code, here I have what each user-defined function would do. So for the non-repeating case, it defines C1 and C2 in terms of lambda and y0 and y.0. Similarly, for the repeating and the complex conjugate, whereby theta here, the point of theta, is defined in terms of arctangent and other variables. Here is a sample output for the first part. So the user would enter a1 and a2, as well as y0 and y-0. And then this is the characteristic equation calculated from the code. Now on to part 2. It is very similar to part 1. However, now I defined 2 files, data text and results text. The same user-defined functions. Similar starting variables, except now I defined 2 more file pointers, fp data and fp result, as well as a line character, which would be used when scanning through the data file. Here I open both data and results file. However, the data is to read and the result is to write. I have a conditional if the file could not be opened, as well as if it was successfully opened. So this conditional statement here, the while loop, would use the line array from earlier to scan each line in the data text file and print all the values in that line. So as we can see right here, it would use these pointers and then print the necessary values. Again, I use the quadratic formula from the header file as well as the discriminant, similar to part 1. Then right here is the same thing as part 1. However, in the print, it will not print to the screen. However, it will print to the result text file. And it will only print the type of equation and then the coefficients C1 and C2. If you recall from part 1, it would have printed the entire characteristic equation. However, based on the project requirements, it will only print these necessary values. At the end here, I have the file cannot be opened as another conditional, and then close the data file if it cannot be closed, and finally close data file and close result file. Next, I open the result file again, except this time it is to read. And once it's opened, it will read the contents, use the line array again, and print the values on each line of this result. Here, then I finally close the file. Here is the same user-defined functions as part 1. And this is the sample output. So what I learned is that no differentiation was needed in the code. It was a simple formula to find C1 and C2. I had a better understanding of pointers because I was not really too sure about it, but after doing this project, I am more confident in my ability. Also, I learned how to better open, read, and write text files, as well as manage this large product into smaller segments. My most difficult challenge was to derive the formulas for C1, C2, and theta, where I had to write out the ODE on paper and use the initial conditions to derive the necessary formulas. And my opinions is that it was challenging but rewarding, especially when I got my code to actually run. It helped my understanding in aspects of C. I was able to improve my code to handle various errors, optimize it, and I think that it could still be even more improved. And it was difficult to grasp before I learned the specific topics necessary for this project. So in class, like I was not too sure about how to do it before we learned about pointers and header files, but after we did, it seemed pretty easy. And that is the end of my presentation. Thank you.